So recording is going. So hello, everyone. My name is Devin Stewart. I work at Tubi. I've worked here for about a year so far, almost coming up on a year. I work on the ad tech platform here. So working almost exclusively in Scala, and now with Kubernetes, now it's like half Scala, half YAML. So for whatever that's worth. So I previously worked at Twilio, and while I was there, I tried to solve a problem that I think a lot of people have had, which is how to manage the stability of APIs in a RESTful world. Since this project started, GraphQL has really kind of taken hold, as well as gRPC. The goal that I had at the time was to take a tack similar to the OpenAPI code generator, but instead of using string concatenation to actually build up the clients and servers, what I would do is use abstract syntax tree libraries like Scala Meta in Scala and Java Parser in Java in order to be able to build these objects using their object tree themselves, so that there's still semantics of what these things are as they flow through the system, being able to have real types referring to the different components as they pass through. That has actually worked surprisingly well. The project is now about 5 years old, maybe 4 years old. But it's gone through a lot of iterations, and the reason that I'm starting to do more meetup talks about it now is as we get closer to 1.0, a lot of the kind of core issues and data model problems that we had and usability issues had been resolved for a while, and we got into this sort of holding pattern, almost like the Linux kernel, where it's like 2.6 like a billion, and it was like, okay, let's just make it 3. So Guardrail's been in production at Twilio for a while, as well as a couple other companies. Avast comes to mind as being a really big early supporter. Avast Antivirus, they just came in and was like, here's a whole bunch of contributions, so we're going to use this thing. I was like, wow, that's great, thanks. So and then we've had a bunch of other contributors over the years. So it's been honestly a pleasure, and I really appreciate the contributors that I've had both internally at Twilio and externally in the community. And so I figured I'd run through what the workflow looks like today using HTTP4S and Guardrail to generate some servers, some clients, and talk about the things that have changed and the things that are going to change before 1.0, intending to be released sometime this year. So without further ado, I will say one more thing, which is please do, if you have questions, shout them out, because you're not gonna be the only one. So definitely want those questions answered, and also in the recording. So please do either say them or message them in chat. Either way is fine. Really appreciate any sort of contribution, because I work better with constant interruptions. So let's do. So to start, I just made an empty Git repository. Actually, I should actually put the, this is the repo that I'll be working out of. So this is an additional benefit for those who want to follow along, or if you get a little bit behind, it's totally fine. It really is the repo that I'm working out of. And what I'm doing is I'm going to be resetting to different points in the commit history, because that's the progression of the talk. So the notes that are here in the README are actually the notes for the talk. And let me just kind of get some focus here. So I actually start with just taking the standard HTTP4S Giterate template and applying that in an empty repository. And so we're going to actually do that now. I've actually already done it, but if we check out to, I think here, we can see 17 actually. So So this is the skeleton. It's pretty standard SPT skeleton. They do the version number breakout. The one thing that tripped me up initially is actually I'd never worked with SPT Polecat before, which is sort of funny as an extremely aggressive compiler warnings plugin. It actually conflicts with Guardrail's generated code, because generated code is kind of difficult to get your imports right and your unused members for code. So even though I added the SPT Guardrail plugin, I didn't realize that I was going to have conflicts with the defaults that came out of SPT Polecat. So you may, SPT Polecat rather, you may run into the same issue, and we're going to fix that now actually. So the next thing we want to do is add SPT Revolver. SPT Revolver we're going to be using to manage starting up and shutting down the fork JVM process, just to make it a little bit easier to exist in this repository. The default SPT run I know has been going through some changes recently, but honestly, it's a bit out of the level of understanding that I have to be able to manage forks and threads in SPT effectively. And I always end up in some situation where there's some port bound in the back end, and there's like, I don't want to deal with that for this. So that's why we're using that. Same thing is with the tpolecat plugin. These are the options that I had to remove from the Scala C options, unused imports and unused parameters. And other than that, we come in here and pretty straightforwardly just define a, let's do that and this. So these are the two things that we just added to the repository, the baseline Giterate template HTTP4S repository using the latest HTTP4S version, latest Scala C. We added a OpenAPI specification. This is my server.yaml, as well as this one line in the build.spt to describe a new Scala server code generation configuration using the HTTP4S framework under the package dev.guardrail.example.routes. And you'll see that this is scoped to compile instead of leaving it unscoped. And this is because Guardrail does compile and test separated scopes. So you can actually generate code explicitly for your test scope in addition to your compile scope. And we're going to be doing that later on in the talk, but I'm just calling that out because you'll see we switch back and forth. And I like to be explicit here just because the compile and the test scopes, if you I mean, if you don't know, or if you don't want to ship your test code to production, right? Like there's no reason to generate something that you're not going to be using. So generate for test, generate for compile, and that keeps things nice. So,
and Paul, did you have a question? I think Paul raised.
Oh yeah, sorry.
Maybe.
Uh-oh. I see a hand, but I don't see a. Was there something in chat?
Oh, not yet. Maybe not.
Oh, disappeared.
Sorry about that. Just me spazzing. It's okay. No question.
All right, good stuff. So let's keep it going with the implementation of that generated server. So to actually let me do this. Let's actually go to before we. So we added, I want to do the one before this. So we added this configuration for SPT as well as that server YAML. So before we actually do anything else in this repository, I'm going to clean and I'm going to run the guardrail task. Let's actually do clean first. There's nothing in target. And then if I run guardrail, what it's going to do is it's going to read from all of its configurations and dump a bunch of generated code into your target source managed. So the intent of this project, and I think it's Happy Path Programming is a podcast that one of the things that they called out early on in that podcast that really surprised me that I hadn't heard someone say before is to describe a mission statement for an open source project and to kind of help people get their minds around it. The mission statement for Guardrail's existence for me has always been to write code that is basically like what you would write, and to not do any sort of crazy workarounds or well, I know that this generated code uses throw, but it's fine because it's generated code and it's tested or whatever. It's like, no, I want that code to be as confidence inspiring as if I had written it myself. And so as a result, at any point, if you disagree with the direction that we go, one of the other reasons that we actually generate source code on disk is so that you can understand it, you can see it. It's not macro reflected into some object that you can't inspect. It's there on the disk. You don't commit it because Guardrail is stable. It's the input that comes in is going to be the input that you get out no matter how many times you run it. So as a result, you don't have to commit the generated code. And in fact, you shouldn't, ideally. That's why with the SBT plugin sticks it in source manage. But you can see that the code itself is fairly short. It's straightforward. There's a little bit of like these parentheses or these curly braces are added as a wart of Scala meta, but they have no bearing on the functionality of the generated code. So as a result, you can read this and you can kind of understand what's going on. One of the big differences between what Guardrail generates for you and what you would generate for yourself, or what you'd write for yourself if you were writing this, is we have the addition of this respond object as the first parameter list in any of your implementations, any of your functions that are exposed as servers through the Guardrail generated routes. The respond object is self-typed to the method name. And it's an object builder that establishes, instead of, well, these are the parameters that are coming into your route, and this is what I'm going to unmarshal for you and give you all of these things, and then you're just going to return an HTTP response or whatever it is to me. The intent behind the respond object is to allow you to describe the different response object bodies in their own branches. So if you want to say, I have 3 responses, I've got a 200, a 201, and a 404 from this one route, you'll get 3 different response bodies described in this list pet response. And the right now, the my server, you can see that 200 doesn't have a content declaration. So there's no body for this 200. It's just a blank 200. That's it. So as a result, you just get a case object. And so if you want to implement this, as we're going to do in the next couple of seconds here, what you end up doing is you just call respond.ok, and that's your response. There's no figuring out how to adhere to your specification as you're writing your code. And most importantly, potentially, if the specification changes, then your code stops compiling. That's for inputs and outputs. So that was one of the other big kind of guiding lights here is I want to make sure that the code generation runs every single time that you run compile. So you don't have to run Guardrail itself. It will automatically gets run when you type compile. And then additionally, that the code won't work if your spec changes and your code doesn't match the spec. So that's a pretty big thing. And so before we go on to the next commit here, are there any questions for what I've said so far, or do we want to dive into anything before we start implementing? I'll take that as a no. So let's do reset to, actually let's do checkout, nope, to 14 So this is the implementation that we will write. And so let me actually do one at a time. So for the guardrail server, we've generated all those generated files ended up in the dev guardrail example routes package, and that's configured in build.sbt. So we import that and we instantiate a new resource builder. This is the thing that actually has the routes, the routing DSL for HTTP4S or Akka HTTP. They're both described as resource. The routes method takes an instance of handler. In this case, it's a pet routes. We'll see that here, actually. So if we look at the handler that we've got in this package, we want to implement that handler. Pet routes is our implementation of it. Because it's HTTP4S, it's bound by some F. The concretization of this is going to be IO, but because idiomatic HTTP4S allows that to be open-ended, you can actually do some kind of cool stuff, like have an in-memory database kind of thing using state T on top of IO or some other monad transformer, or even just a custom monad that gives you instances of sync or async, but that offers some other functionality. You can just kind of wire that directly into your service, and you don't change any code except for the routes that need that stuff. So that is a surprising, or maybe not surprising, benefit, but it's definitely one of the things that HTTP4S gives you, which is pretty great. We wanted to maintain that as much as possible. So as a result, when we implement this list pets, we see this respond method, and it is exactly like what we just said. This responded okay is the response. We're going to send back a 200. I don't actually want to see 200 in my code. I want to know that I'm talking about symbols and that those symbols map to reality. So internally, there's a map between okay and 200, but I don't have to worry about that. We lift that into an F, and that's whatever container, whatever type class we're passing in here. And then we have to widen the type because of F being invariant to change. So because OK is its own self type, then in order to get to list pets response, we have to call widen on it. It's just a thing you do in the CATS world. If we then look at our test, we can actually see what the implementation of this on the test in the test world would look like. So we take our implementation of pet routes, and because we were just responding with an empty OK, we expect that if we call the pet's URL and we pass in the just no body, no parameters or anything like that, we expect to get immediately returned an empty string, because empty bodies treated as text plain, decoded as a string, will just return you an empty string in HTTP4S. So as a result, that's what you get. And we can actually reload this here, and we can run the tests and check to see whether or not that assertion comports with reality. Sure enough, it does. Nice. And so the nice thing here, and let's see if we can let's continue to the next commit. But I think we're going to end up here. Oh, this is the cleanup. Yeah. So just deleting the rest of the generated code that they supplied for us, because we don't actually need that in this talk. The intent was to combine the guardrail generated routes. So we did, even though I didn't call it out, we actually just combined the guardrail generated routes with the scaffolding generated routes from Giterate. And so this is a great way to either add your new guardrail routes ahead of or after your production routes. So if you want to add new functionality without impacting production, add it after. If you want to start migrating code over, than Atom before. And we've done that actually at Twilio. It took us a number of weeks because we did a fair amount of bake-in for each of the new routes that got converted. But it was actually a small anecdote was it turned out that the parameters that we had for one of our routes, and this is one of the biggest wins that I've seen Guardrail provide personally. The way that our previous code had was written, the way that our authentication service ended up working, it either accepted pre-authenticated routes from request parameters or the result of hitting the authentication service. And it was like this option or else this option. And because it expected one or the other, it didn't expect both to ever be empty. But if the authentication service ever went down, then everybody would be able to access everybody else's resources. So it's sort of a weird edge case, but being able to describe this is the state of the world, and we need to see the world exposed in a sensible way, in sensible specification here. This is the Open API specification for this service. We converted it over, and actually we had an intern who's doing the conversion. The intern came to me, he was like, I can't get this to compile. It's like, it's wrong. It's like, it's been wrong. And the only reason we found it was because we started trying to actually impose rigorous coding practices to our existing services. So pretty surprising win. And I'm keeping it intentionally vague because, first of all, I like Twilio as a company. And second of all, because I think it could pretty much happen to anyone, anywhere. It's such an easy thing to just have these preconceptions and without the computer there to enforce reality or enforce limitations on your implementation. It's super easy to make these mistakes. So definitely not calling out Twilio. I mean, we wrote it, right? So as a result, it was sort of a surprise and an unexpected win. So yeah. I see a chat. Let's see. Oh yeah. So so this commit was just cleaning up, right? So we cleaned up all these things, the automatically supplied routes from the git-iterate template. We're accumulating this change set. And I'll do a reset hard every so often, but I still want to just kind of run through these one by one. And so the next change here is going to be adding a response type to that 200, right? So it's just going to be a plain application JSON string. So if we just add that and don't change anything else, we can actually try to rerun the tests, right? And what will happen is that, first of all, it actually regenerates and it tells you, hey, by the way, I wasn't expecting your generated code to fail or to change rather. And this is the first kind of canary in the coal mine for something unexpected happened. If you expect your spec to change and you see this, great. If you don't, and you see that, you may want to check something. Sure enough, our response here is just wrong because instead of getting a list pets response, now we just have the single to type of that OK object, and we are expected to provide an implementation. So if we look at what that looks like in metals here, so metals is helpfully telling us we expected a list pet response use supplied object. So if we look at the apply method, can I do an apply? No. Well, close. Thanks. Almost thanks, metals. So if we just try to compile with that, it'll say, okay, we expected this parameter value. If we supply something this completely nonsensical, it will tell us, by the way, we wanted a string, so we supply like fluffy, and it will then compile, and then the tests won't pass because it turns out that expecting an empty string and getting fluffy is an unexpected change for the tests. So let's check out the rest of that commit where we change the response to fluffy and Fido, as well as modify the test to instead of getting an empty string, let's get a JSON, because this is an application JSON endpoint, and return the JSON from string with that JSON string. So that will not only not show us the warning anymore, because the warning has already been shown, so that only gets shown the first time the file changes on disk, but then additionally the test now passed. So we're once again aligned with what our specification says. The code all works, tests all work. It's very good. So the next thing is to talk about, instead of just bare strings in JSON are super fun, but not super useful. So when we are looking at extending our specification, we can either do that by extending them with objects defined in our own code, which is typically what you would do with HTTP endpoints. But that's only of limited use, because those objects have to be defined in every language and on every code base. So you either have dependency hell, jar hell, whatever, or you have the same problem that we had initially, which was that we were just rewriting the same objects in Scala and Java, different versions of Scala, different versions of Java, like standard library versus Vavr or whatever. It just became a real pain. So this is one of the other things that we wanted to do is to track the objects. It's nice to have a specification that says what your specification is, but we should be able to also use that specification to describe the objects themselves. So we end up getting, guardrail will generate these objects for us. The definitions come in this, so because the pet has two required fields, ID and name, the tag is not required. So it's just going to generate a constructor for pet with, it's just a case class with ID as a integer in 64 in OpenAPI, that's a long, and a name, which is a string, and then the tag is just going to be an option string. So it's just going to be 3 parameters. So we supply 1L fluffy and soft for the tag, and 2L Fido, and Fido's a bit bitey. So as a result, we can run the server now. We update the tests as well. Because we're requesting JSON, we can just provide JSON literals through Circe, and we can actually look at what the tests look like now. Because we altered the specification to have those new models. It's also having to import more things and supply new parameters to our method. So as a result, or rather not new parameters, just the new import. So we can run the test, and that should run. And we can actually run in SPT, we can start the service up. And we can pop over to this and take a look. So if we hit that, we end up getting our JSON object. We can pipe that through the industrial strength JSON. We get all the fields that we expect. If we were to, for instance, change the sum to a none, then we would again get what we expect, which is null there, or even just leave it off because the default parameters should take care of it. That gives you the kind of quality of life that you would expect from the objects that you generate. And then additionally, if we look at going to the next commit here, let's add a query string parameter, this tag, but instead of just having it just be a string, let's have an array of strings to allow you to repeat that query string parameter. And what that will do is it'll allow you to filter by one or more tags. So we can just take this new parameter, this option iterable string. In newer versions, there's a PR that's about to be merged that changes this to a vector instead of just iterable. But right now this is a wort from long in the past. I won't dwell on it too much because it's about to go away. But we can take that tag parameter, and we can filter all of our pets using for all on the tag. So if the tag is not present, then we just return all the pets. If the tag is present, then we check to see whether or not there is a tag that exists in that iterable such that the pets tag also contains that. So if the pet has no tags, then obviously it can't be in the return set. And if the tag doesn't match, it also won't be in the return set. So that should just work. And if we try to run that same curl, we can do that, which is great. But if we also stick this tag, what is it, soft, we can see that only Fluffy is returned. If we change it to something else, then nothing is returned. But because if we do bitey and also soft Z, then we get Fido. But if we put the soft back in, we get Fluffy and Fido. Fluffy and Fido both returned. So having sort of a little bit of PHP flashbacks of having array, like the little brackets for the query string, but we don't have that here. This is the future. So let's do the next commit. And we can look at, this is just a simple refactoring commit to move the pets vector out from the list pets object, or rather method, as we're about to add a new functionality as well. If we look at the get pet method, so this is going to be a 200 if we found a pet, or a 404 if we did not find the pet. We're just going to return a simple string. And also I'm speeding up a little bit here just because I want to make sure we have enough time for questions at the end, because we're still only on commit. I think we've got 9 more commits to go. So I want to make sure we get everything in there. A simple implementation of this is to filter to see whether or not the IDs match. Our new method does in fact take that integer int64 and translates that into a Scala long. We filter by ID, head option on that list, and or on that vector, and we fold, pinning the response type here because each one of these is going to be their singleton types, and we want to widen that type, but we're just using options fold. This is the standard Scala fold. We respond with a method, a not found, a 404 method of no pet found, or we just take the pet and apply it to the OK. So we return that pet immediately wrapped in an OK. So that should also run. And it will give us an API that we can hit with these 2 different IDs. Actually, I did mention one other thing on my server, is that the parameter for the ID is embedded in the URL itself. So we listed the parameter here, but it's a path parameter in Scala, or in OpenAPI rather. We're using Atto from tPolkat actually to parse the URL. So if your parameters don't match up, we also try to give useful errors. So I think, for instance, if we delete that, we will not get an error there. Well, that's a disappointment. What happens if we say that we have a parameter, but we don't actually have a parameter? Yeah, there we go. So failed to parse the URL. We expected to find an ID, but I wrote a thing called tracker inside guardrail, which is sort of like a lens into POJOs. So because we're using the standard OpenAPI parser, it's just a bunch of Java objects, and that was really unpleasant to deal with. And we also really wanted to have great error messages. So this will tell you that, by the way, we expected to be able to parse this ID. This is not the best error message, because what do you do with failed to parse URL end of input? But we do actually show you that we are trying to traverse paths and the pet ID, and that's where the failure came from. So if you have a really long OpenAPI specification and you have a particularly more, if you're just getting a specification from somewhere and you're trying to run it through guardrail, you should have contextual kind of bounds for where to look for where things are broken. So that's another thing that I think we're either getting close or we are there as far as offering great error messages. That's something also I'm pretty proud of. So if you find error messages that are not helpful, please report them as bugs, because that's something that we want to make sure we're helping people be more effective. So if we hit pet and 1, we should get Fluffy. If we hit 2, we should get Fido. And if we hit 3, we're going to get the message. And actually, it's still JSON, so we'll just render it as green. So yeah, that's great. And we still have all the middleware that was offered by the HTTP4S Giterate template. So we're getting the nice logger and all that stuff that was already pre-configured for us. So there's it's pretty straightforward to start up and start getting your functionality kind of wedged in there with all the rest of the stuff that comes out of the box. The next thing is to use Guardrail to generate a test client for our service that will let us, instead of using raw HTTP4S in our tests, I want to also just be able to use the methods that the same exact methods that I just used from the server. I want to use those in my test as well. So I should be able to just say, I'm going to get a client from my backend service. You can run it through this client from HTTP app, which will take the service and turn it into an HTTP4S client for you. Something like this exists in Akka HTTP as well. So if you're using Guardrail with Akka HTTP, all this stuff will just work. The exact same concept will map over there, and lift that directly into our generated client that we just put from here, using the same parameters before, except instead of example routes, we have dev Guardrail example client. And we should just be able to call list pets on that and expect an IO of list pet response. And our response, we know, is going to be a vector of these objects. We're no longer dealing with it with JSON. And so we'll just be able to get a vector of the generated definitions from the client. So all of that stuff should just work out of the box. And if we try to run that test, we will see we actually have to reload because we changed the Guardrail configuration. We will see that not only should it work, it does work. Look at that.
Nice.
So yeah, that would be unfortunate if it didn't. It was just working. So and I said I was going a little bit fast. Does anybody have any questions? I'll just keep going otherwise. Okay. This one's going to be a test for the other. Let's see, is the code in the diffs we are seeing generated by the lib? No, that's actually a great question. I wrote all this generated code, or rather, I wrote all the code that's in this repository. So the intent of Guardrail is to generate its code from scratch every time that you run compile if it needs to. It does caching internally, but if it sees that your specifications have changed, it will rerun the code generator. So the only reason that I'm doing this in this way in this talk is just because I had a lot of material that I wanted to cover, but you can see that let's look at 19 commits. So all of these are written by me, right? So you can look at it should be in the chat. Yeah, yeah, no, you don't need to worry. Guardrail's not going to modify anything that's not in source main. Or target source managed rather. It's not going to modify anything in source main. So it's all good. Yeah, the next test that we're going to write is a test for get pet. So I want to check to see that not only can I get pets, I want to be able to get the empty pet, the non-existent pet as well. So I'm using the flat map type class from cats to use tailrec_m, which will let me do tailrec, but over some IO or some F or whatever. So I'm going to get the flat map instance for IO. run tailrec starting at 1 is my starting ID. And each time I'm just going to call get pet with that ID. And this is a new concept, this fold here. Let me actually run guardrail. And then we can look at targets, Scala source managed. Let's look at the client. So for get pet, so get pet response here, you can see that all of this is just the marshalling and unmarshalling of parameters and whatnot. But the important thing is that we've got the get pet response object with these case classes. The OK will just contain a pet, and not found contains a string. But importantly, we also have a member as part of get pet response, which is this fold that has these handler methods. Since you can match on the branch of all the types, you can get exhaustivity that way. It's totally fine. But sometimes you want something that's a little bit more terse. And so we're going to actually use that in this test as well. The handle OK is just a pet to A, and handle not found is string to A. So no other modifications other than doing the case matching for you and returning the result of calling your function. So as a result there, if we look at this spec here, we can see fold. And so we're doing this tailrec inside this IO. So we're doing a map on the IO to get access to the response object that we got from the client. And then we're folding on that and saying, okay, if I got an OK, that's fine. I don't actually need the pet, so I ignore that. And then I'm going to return a left with ID +1 to increment the internal counter, the state, the accumulator of this tailrec M. But if I got a not found, if I got a 404, I'm just going to take that string and slap it right in a right. And that right will trigger the end state for tailrec M. So I should, for this whole structure, get a IO of string returned. And because we're in assert IO takes care of the IO, so I should just have a bare string. The bare string should be no pet found with ID 3, because first of all, we expect that to be the case. If we hit that, it's not running. And we will see no pet found with ID 3. It's a because we're unmarshalling the JSON and giving you the bare string, you're not having to deal with JSON here either. So we don't have to do the JSON from string stuff that we did before when we were dealing with the bare response objects. So that's another benefit you get. Nice. So yeah, I don't want to have to deal with JSON, but if I'm dealing with the protocol level stuff, I've made a mistake. But I should say that there is actually my server. If I say, let's do like X server, Scala server raw response, I think. This, I think it's X Scala raw response. No, server. Don't use this very often. Yeah. So if you run into a bug in guardrail where there's some feature that's missing or something isn't working correctly, you can actually pass that X server raw response. It is documented. I just didn't have the documentation pulled up here. But for this get pet, we should actually see that the response type, instead of being our get pet response, now we just have the raw underlying HTTP4S. So if you need to, you can kind of rip all the stuff out and just say, here's my raw response. So I can violate any of the generated codes, assumptions, or whatever. I know what I'm doing. Here it is. Because it's important to have safeguards and escape hatches for generated code, because you can really kind of architect yourself into a corner if you trust the service too much or you trust the library too much. So that's another thing that from the beginning is like, okay, we think that we're doing something good here, but if we're actually making a mistake, we still have to trust the operator. So that's another big thing. So let's go to the next thing, which is to one of the things that we deleted from this repository early on. And actually, how am I doing for time, Andrew?
I think you're good.
Okay, cool. So the one of the things that we deleted from this repository when we started was an HTTP client that made a raw call to icanhasdadjoke.com. I thought that was really great functionality. I think every industry service should make a call to icanhasdadjoke and include it somewhere. So this is their API, a simplified version of it. GetJoke returns a joke, and the joke has one required field, which is joke. So we are now going to generate a client in our compile scope for that, because we definitely want that going to production. We're not actually going to use it yet, but we can take a look, I guess, at the source managed main com icanhasdadjoke with client. So it's just a standard client, the same one that we saw before in our test code, actually, against our service, with the same response types and the same object mappers and marshalers and unmarshalers and whatnot. So the reason I'm calling this out is because this client is called the same thing that other clients called, which is client, sucks. It's terrible naming. So eventually you're going to get sick of everything being called routes and client. You're going to want something more specific. So let's remove the client package from that and actually use xScala package, which is another vendor extension that we add on top of OpenAPI. And if we just with that change, we'll see here, clean guardrail. What we'll do is target. We can actually see that the client has then been prepended with the package. So the package is already part of here. Joke is there. And then the client name includes the last segment of the package, just for convenience. But that gives you a way you can stick a whole bunch of objects all in the same package, and you can have them named using that vendor extension that will give you that functionality. So one of the things that we now have the ability to do, because we have this dad joke client, is we can actually make the pet not found response, instead of just telling you that the pet wasn't found, it can at the very least try to cheer you up with a joke. So we're going to slam that right in the response object for this thing. And writing this talk, I actually found a bug in the HTTP4S generator for guardrail. So one of the things that we did, and I think a lot of people do, is just presume that everybody is just going to be talking application JSON all the time. And certainly that was a pattern that I fell into. There were a couple of times where there was something that was text plain, but it was actually secretly JSON. And I've never run into the other way, which is a backend that actually understood and had sensible fallbacks for the different content types. So that was new integration surprise for this talk, running into that issue, where it turns out that no, they sensibly fall back to text plain. If you make a request, they will just send you a text plain response with the dad joke directly in the body. That's customer service, honestly, right there. But because we're expecting application JSON, doesn't work. So fortunately, with HTTP4S, if you have an existing client, so we've got this underlying client builder object, and we want to take a request. So our request is here, the incoming request that I'm using a lot of we's here, so I'm trying to describe this sensibly. So joke client is going to receive a call from your application code. It's going to translate all the parameters from Scala into HTTP land, into HTTP4S in this case, and it's going to take a request that is all of the stuff that you wanted bound up into this request object, and then pass it to the underlying HTTP client. You have to supply an HTTP client. Doesn't matter if it's a stock one, like a static one. We're going to be writing a static client in a couple of minutes here. Or a live client that hits something configured with a proxy or whatever. Because that client is just a function from request to an IO of response, we can take that request and then just extend it with stuff. So we just take the request and kind of shove a whole bunch of new headers in there. In this case, just one, which is that our accept is a list of application/star. Fortunately, application JSON matches application/star. And fortunately, application XML is not something that they offer. Otherwise, we would have to deal with that. But we're just saying, okay, I just want to put this application star in there. Give me application JSON. So that explains what's going on here. I did open an issue for it, so I'll try to get that fixed. So joke client, we're going to pass that into our pet routes. Pet routes now has the joke client as a parameter here. And I'm just going to call joke client get joke and get the response. I'm going to fold on that. Handle OK is going to take the joke. I'm going to unpack the case class, and I'm going to take the respond not found, and I'm going to put the joke right as the second parameter, that not found response. And because this is HTTP4S, because this is all IO, this, even though this is calling get joke, right? This is something that's doing a network call. It's actually not going to be evaluated until it's flat mapped into something else. So I can actually define this up here as a val. It's going to be delayed until it gets returned from this function call. So I can, instead of having this line be super long, I can just define it out here, pass it in here, widen the type, and then that's it. We get the pet, return it, respond OK, peer F, widen as well, to make sure that the types align for the left and the right side there. And now, if we reload and restart, we will get, ideally, sure enough, new changes and curl. If we hit that pet 3, we should actually get, first of all, it takes a little bit longer. The joke is 2 satellites decided to get married. The wedding wasn't much, but the reception was incredible. Is that funny?
I mean, it's a dad joke.
Yeah, that's fair. All right, well, so it worked. So that's good at least. So let's do, getting down to the end here. So what happens if the joke service is not available? Or if there are no dad jokes in the database, somebody logged in, little Bobby tables, tried to register, drop the database. The joke is now optional. And if we get a joke, then we can give the joke. We just take the joke and say we have some joke. Otherwise, we return none for that object. This is just because the only reason we have to make this change is because we removed the joke from the required parameters on this pet not found response, right? So that changes the case class that's generated from having a string as the second parameter to an option string. We have to make that change because in our test, we want to be able to use that static joke thing, but we don't have a static joke service yet. And because one of my kind of guiding principles is to have atomic commits and having everything work at the end of every commit, barring one commit in this repository where I didn't do that, but everything else all the way through, tests have always worked and everything's compiled. So you can definitely check out this repository and go at any point in the past and run the code. It will probably work. The response here is just going to get the message out because we still want this no pet with ID 3. But if we have a static joke client, one that's not going to hit the internet for our tests, we're just going to return HTTP app not found, which is just going to say every request that HTTP application gets is going to return with a 404, which is why we had to modify our spec to allow 404s. So that's probably good to represent your errors in your spec because that's important to be able to handle errors. We had a whole bunch of manually written clients that were all just like, yeah, the world's great. 200s for every response. Totally work. Doesn't even matter. So that's not a proud thing to realize, but you know, it's a thing that happens. So we include that not found so that we can do this in our test, but it's also good practice to do in the real world. We are going to actually run the tests now. and check to see what happens. So this should also just pass. Sure enough, it does. The next commit is the interesting thing. So we've already done one thing, which is take our backend server and generate a test client. Now we've got our production client and we're going to generate a test service. So a test server implementation for that client. So now these are test scoped imports, and I'm going to write a static implementation of the I can has dad joke service. It's just a simple handler. Implement that thing, respond to get a joke with, this is a joke. Sort of meta humor there. This is not, it's not funny. So then we take the joke resource, pass in our static joke handler, turn it into an HTTP app by calling or not found. And then our static joke app now works. We need to reload spec, and we will see that rebuild. So we will see that the tests now work. The joke that we got is this is a joke. It actually gets matched here because we made the change. Let's get show here, right? So we made the change here. Instead of getting the message out and just having this no pet found with ID 3, we removed the map. So we're getting the whole pet not found. Respond. I can actually trust that'll is held if so long as the specification is correct. This is a huge benefit if you're working collaboratively across time zones or with teams, having a single specification that can be iterated on and just start implementing on both sides. Nobody has to implement the spec or the spec is wrong or whatever. You just start and you run in both directions and meet in the middle once everything's done on the other side. So super, super helpful to be able to write these kind of static mock services on the back end in your tests. Did that for a whole bunch of our internal services at Twilio. And we had basically integration level tests for our functional tests. That was a just massive benefit. It was huge. Yeah. So let's do the last commit here, which is getting back to master. I think that actually is it, because that last commit was changing the formatting for the README. So let's do a final reload just in case there were changes. I don't think there were. Restart. And that service should now give us, we saw our dad joke before. We can still get our pets and we can still tag fluffy, soft rather. Yeah, we can still filter. So everything still works and we're at the end of the talk. So I'm, that's kind of where I wanted to be. So we're going to talk a little bit about, just to wrap things up, the roadmap for this year. I'm hoping to have 1.0 released. I'm going to say probably Q3, Q4. The main thing is I'm trying to shore up a lot of the changes that we had to incur in the code generator for the Swagger to OpenAPI change. When OpenAPI was released, they changed all of the data models and a whole bunch of stuff internally was shifted and altered for the better. Tremendous benefit. But as a result, there were a whole bunch of places where we were matching on the tuple of a string for the type and an option string for the format, because the Swagger specification, the Swagger parser, was just throwing around all these bare strings. And the OpenAPI parser, they've done a tremendous amount of work, and it's been a huge joy to use, where they actually describe the object model as real object hierarchy. If you look at an array, if you have an array of objects, you can actually get the internal schema, and it's all of the same super type. So all of our explicit object and type mapping code can all just be reduced into a single code path. Huge benefit there. It's been it's been as I said before, it's been a joy. So I've got a PR open right now that unifies a whole bunch of those things. And that's one of the reasons why the iterable type in the consumer generated code is going to be changing to vector. It also shores up a whole bunch of bugs of like, well, this behaves like this over here, and this doesn't behave like this over here, or like this extension parameter isn't able to be used here because we just don't have it because it doesn't exist. But then additionally, because we're now traversing the full object model that whole way, are the breadcrumbs that we have in our error messages don't just start randomly. They actually truly do come from where they were in the history of the specification. So there, for the most part, we were able to do all that work, but it got a lot better as we got closer to having all these things be unified. So without too much hand wavy stuff, that's basically what I wanted to talk about, and to kind of put that out there to partly as motivation for me, but then additionally partly just to share like my excitement for where we are right now in the project. So yeah, it's good. We've got a fair number of contributors actually, and I'd love to have you as well. Anyone who's listening to this currently or in the future. I try to be responsive. We've got a Gitter channel as well. And so there's not a lot of activity in there, but I check it constantly. So if you have any questions, any bugs or anything like that, feel free. I'm always available. Ping me. So yeah, thanks for your time and the questions that we did get throughout the talk. If there's any more questions, I'm happy to answer them now. Yeah.
Bravo.
Thanks.
Yeah. Cosmin, is you?
Yeah, can you all hear me fine?
Yep.
I just want to say great talk, really, really interesting. Question about just like how you end up using the specifications. Do you find yourself that everybody kind of starts with a spec file, and or are the spec files somewhere in a central repository, and then you kind of import them somehow, and then everybody just goes on, it just generates the code off of those?
It's a good question, and it's a contentious one. There's a huge benefit from having a central repository of those, and you can have network accessible specifications. I can tell you as a fan of reproducible builds, however, unless you have content addressable URLs, your build will just suddenly fail. And if you're in the middle of an incident, you don't want your build to stop working. So for me, the file system is key, and having a directory of those specifications in your project, versioned ideally. The OpenAPI specification does actually have a version field in the spec. So if you have consistent versioning, and if you have the policy internally to maintain that and to adhere to it, you should be able to, at a glance, see treat your end services like Semver. I think is a great way of thinking of this. Is that if the patch version changes, your clients should still build, no problem. But the functionality on the service changed. Maybe there was a bug, but the server API didn't change. The minor version changes. You don't have to rebuild your clients, but you're maybe missing new functionality. Major version changes, you better hope that you've updated your client, because there's no guarantees about the API anymore.
All right, thanks.
Hey, has there ever been any, so it seemed, starting with the Open API spec and then going from there, it'd be really cool for like coming off of like a Spring Boot application and, turning it into a Scala app. Have you ever looked into anything where you are using some kind of static way to define the actual Open API spec itself? Like Tapir, for example, you can use all your Scala types and it spits out like an Open API spec, and then you can use that for this library? Like, have you ever looked into anything like that or tried it?
Yeah, actually. So in Haskell, I was using, I think Servant has something like this. There's actually, I've spoken at length with some of the people who maintain Tapier, as well as the guy who wrote the open API generator for Servant. And I've been on issue trackers and whatnot with people who maintain the official open API and Swagger reflection libraries. Everyone has done a tremendous effort making that stuff work. I have used those tools before, and while I think there's benefit to them, what it's doing is it's restricting your general purpose coding language to be something that's understandable by the reflection library, right? So while it's possible, the problem is you're fighting this, what I would describe, I don't mean to offend, you're fighting a losing battle, because instead of having a restricted language that contributes code to your general purpose language, you're trying to constrain your general purpose language to be something that can be statically analyzed. And if you've ever played around with the routing DSL in Akka HTTP, for example, good luck trying to read that. Like it's an amazing thing. It's truly a Herculean task to actually have something that works so well with the magnet pattern and all of that stuff. Like it's wizardry how it works, but it's impossible to inspect. It's just literally, there's so many different combinations and ways that they can go together. I won't beat the horse here, but it's not, I think it is promising more than you'll be able to get. As a great example is what happens in the fallback cases. What happens if you can maybe reflect out, for instance, I think at the beginning of your question, you mentioned Spring Boot. We have Spring MVC as a target in Java where you can generate Spring MVC code out of guardrail. The annotation-based approach to reflect that out of Spring Boot, maybe you can represent all of the different cases of different content types, different response codes, different response bodies for those response codes. And like there's a whole bunch of these things, but now you've crammed all of that domain knowledge into a single annotations parameters. And if you miss something, I mean, we're all human, right? How are you going to make sure that you didn't miss something? You forgot to update an annotation somewhere. I think, again, it's a tremendous amount of effort put forward, but I don't consider it to be a long-term way to go. And we even use Tapier at Tubi. So I hesitate to even say like it's not production ready, because I mean, clearly it is, and a lot of people love it, but I don't think that it gives you the level of stability that I was trying to get to. So hopefully that doesn't offend too many people. There's a lot of people who know it, love it, and put it out there, but yeah.
Very thoughtful answer. I appreciate it.
Of course.
Yeah, I've personally always been more of a fan of contract first, but I feel like I'm generally in a losing battle in that.
Yeah, I've been there. I've been there.
You kind of mentioned some of the open API changes. Since guardrail has been around for years, and were there any I don't know, iterations of the open API spec or Swagger or whatever that they kind of were particularly a headache as far as upgrades or like new features that were added that you're like, oh my goodness, how am I going to get this in the guardrail?
If I were to be honest about my initial goals, so in order to get guardrail out in the beginning, we had this whole from the ground up, always use Scala Meta, very early, or like even the prototype, like day one, when we were just doing this on a hack week at Twilio, we used Scala Meta for that. We also used the Open API, or rather the Swagger parser at that time, And we had a lot of hard-coded assumptions about the Swagger specifications, how they represented things. We put all those assumptions into the code because you kind of have to. But then when the OpenAPI domain models came around, that really threw everything it completely sideways. Previously, there were parameters were a completely different object hierarchy than schemas. And so if you had a parameter, your parameter would have a different set of arguments, a different set of fields than the schemas that your objects would return, or that your endpoints would return, right? And so trying to unify that, we did it a whole bunch of different ways, wrote a whole bunch of really cool kind of generic stuff. We were talking about shapeless earlier. No shapeless in guardrail, but inspiration from shapeless definitely in guardrail. And there's a lot of stuff that really just got thrown sideways. And then we ended up finding a bunch of bugs in the OpenAPI parser itself, where they would either not populate a field. I think there's still an open issue where they just made up a name for the body, because in OpenAPI, your body parameter, the content parameter, doesn't have a type name. Like, it doesn't have a name anymore. But it did have a name in Swagger, so you could actually say in body name this. And so they just called everything body in OpenAPI. But as a result, now if you had body in your Swagger as one of your other parameters, now you can't name a thing body. So one of the big challenges that we've had is to constrain the scope of user controllable field names, user controllable parameters, making those very explicit. Like, okay, this is where the pedigree, this is the explicitly fully qualified package name to get to this type name, because there's no guarantee that your user is not just going to describe an object as response. And it's like, okay, well, what response is that? Is that HTTP response? Is that, or awk HTTP response, HTTP4S response, drop wizard response? Like, I don't know. So now you've got this conflation of terms. And so going back and trying to annotate all the different, pedigrees for these symbols that we just threw out there because, of course, this is not going to fail at all, ever. But sure enough, it did. So that was another thing that really kind of bit us, was the lack of foresight to think that name collisions would be an issue with generated code, because we were our own consumers and we obviously just didn't name our stuff that. So, but I was like, no, the real world exists. Like there's an issue from, or maybe this is an email. I don't know. I don't remember, but somebody from a Fortune 500 company just opened an issue or sent an email with an OpenAPI specification that was like 20 or 30 megabytes of text. He's like, I'm having problems generating this with guardrails. Oh my God. This is the worst.
Oh.
Why? He's like, well, I can't modify it because it's coming from upstream. It's like, oh my God, this is horrendous. So there's stuff like that. And then also there's on the pursuit of really good debuggability and introspection. I had this idea for structured logging, and the code's all still there, but I had to disable it because it was just such a huge performance regression. I got an issue or an email after I released a version, and the guy's like, yeah, so my code generation used to be okay. It used to take 6 minutes to generate my guardrail specification, or my code from my guardrail specification. But now it takes 20 minutes after the last. It's like, what? 6 minutes is already too much. So I then went like crazy with performance optimization and got I hadn't even realized, but I'll show. But the no, come on. Yeah, here's. So the guardrail tests themselves, there's I would say it's like 3 or 5 levels of testing, depending on how you cut it. There's whether or not the generated code compiles and then we run, or rather whether or not the code generator can run at all, and we run runtime tests in memory against the output of the generator. And then we try to generate from a bunch of static files onto the file system. That's another level of testing. And then we try to compile the generated code against different compilers, different libraries. And then we try to run tests in the generated code. And so we have end-to-end round-trip suites that exercise different functionality at runtime in the different frameworks, and that runs on every merge to master. But one of the things about performance that I didn't realize is our regression suite had actually gotten quite sizable. So we have a lot of these example specifications that all cover like weird edge cases or issues that people had.
Mhm.
And it was like it takes like 15 minutes to run. It's fine. I don't have to deal with it. But it's like, oh, it's running every single one of those things, and that's a really great performance test to make sure that our users are correctly served by the guardrail generator itself. So that was another thing. Is like, okay, we need to have really good tests. We have to have confidence in what we put out, but then also, man, that should be fast. We shouldn't just be burning CPU credits. It's like, okay, Travis is free for open source, GitHub Actions is free for open source, but I mean, there's no reason to just sit there and burn CPU for no reason. So yeah, spent a lot of time trying to improve the performance there as well. Any other questions, or want to talk about Scala Meta, or want to go and, you know, do something else with your lives instead of just listening to me up? Anything is fine.
One question you briefly touched earlier, you know, it's kind of at the beginning about GraphQL guardrail for the time being is very much staying REST open API spec, or basically.
Yeah, I know what you're asking. So the one of the other things that I've had in the back of my mind the whole time has been this idea of cross protocol services. And so to that end, it's actually possible. So the spec here. So if, for instance, if I have the service, which is coming from this resource, but if I just pop this out, right? So this is the service, what is it? Pet handler. No, tpolecat will yell at me at some point. So one of the things that you can do, because these are all just, there's a strict separation of concerns between the handlers and the routing layer in the resource. You can actually implement that yourself. So we have done, I exposed the same API using the exact same code between Kafka using some protocol that we just bespoke wrote, using that same handler instance to bind to HTTP, as well as to handle the different calls internally and externally from Kafka. So I don't have that code anymore. That was internally at Twilio, but the pet handler is just a thing, and you can say get pet, and so long as you say resource get pet response, right? And I say like 1. What I'm going to get, just to make it complain, I'll actually get pet resource. This is not what I expected to see. Pet routes. Oh, pet resource. Pet routes. No. Oh, resource is not imported here because it's not. Yeah, there we go. Much better. So, right, and it's saying, hey, I expected to find a long, but I got this get pet response. So sure enough, you can say, I'm gonna take this thing and do whatever with it, and just pretend like it's a normal interface, right? You can do that kind of thing if you need to. And in fact, that is a design goal of the project. It's just not one that you can communicate particularly well. So being able to share, I actually even have, it's sort of funny, in the history of this repo. I was going to go over this at some point, but then I kept writing the examples and the code got out of date. But I actually did delete all of the HTTP4S dependencies and then changed everything over to awk HTTP and out of the awk HTTP dependencies. And this was the change to, let me actually do show-w to see if that minimizes some of the changes. The changes to the guardrail generated handler were remove the F, change F to future, and remove the pure F here as well. And that was the whole change to the handler. The intent of making it easy to change frameworks is also a design goal, because I think that the implementation's details, once you can abstract away the protocol, the implementation details of your business logic should be identical to whatever it is, no matter what your protocol is, right? Mm-hmm. So being able to describe that as an explicit interface with, there's no 200s, no 500s, whatever. Like I had to beat people with sticks that were chasing me inside Twilio. They're like, I want to send a 500. Like, no, you don't do it. Because it's like, as soon as you let that in, as soon as you're like, oh, I want to be able to turn this random integer into a whatever, it's like, okay, there literally is no way to do it inside guardrail. You can do it if you want to. What you'll do is you'll end up saying, okay, I've got this fold, handle not found is actually going to be a 404, and handle okay is going to be 200. You can do that. Now you've done the mapping yourself, but importantly, the mapping is done by you in your code. Yeah. So it's a very important thing to be able to say, well, we need to start talking about higher level constructs. We need to start talking about like symbols instead of magical numbers. Like I don't care about my protocol. I care about my business logic. And then something else should care about the protocol, or I should care about the protocol, but I need to put on a different hat to do that. So yeah, that's definitely a goal, but it's very hard to motivate.
Yeah, but and maybe realizing that obviously those are large changes. One thing that we've hit recently with, like, we making more and more use of specs for our services, but we use at work, we use Logum, and they have, for the streaming APIs, they're generated as basically like webhooks, more or less. And we found out, come to find out, that OpenAPI does not handle webhooks well, or not WebSockets.
Yeah,
WebSockets. Yeah. And I ran across like the async.
Yep.
Open async or something like that.
Yeah. Yeah. I don't remember what it's called, but I know what you're talking about.
So we've had some discussions internally about whether that, like, do we pair them together, or since the async one is supposed to be a superset, do we kind of go with that? And or do we haven't really settled on anything yet, but
yeah, I don't think that the data models will be the same. So it wouldn't be straightforward to make that change. And it would definitely complicate the internals of Guardrail quite significantly. But one of the benefits of getting away from bare tuples embedded with this kind of presumption of how the world looks like based on a view of strings, right? That gets us closer to a model where we can talk about some sort of sane object hierarchy and having sane types and sensible code paths and handling based on whatever parser library we're using. I wanted to, at the beginning of this project, I wanted to take the OpenAPI specification, at that time the Swagger specification, and run it through an OpenAPI, or run it through a JSON schema parser generator, and generate my parser from that thing so I can be as close to the specification as possible. Mm-hmm. And then if they change the specification, then I just regenerate my parser, and that's it. But I contributed to a bunch of parsers at the beginning of this project. It was like, this isn't going anywhere. None of these parsers support the level of flexibility that OpenAPI needs. And then this whole process of getting guardrail written would not happen because of kind of ideological purity. But if I did stick to that, or if I can kind of guide us in that direction, it may get us to a point where it's very easy to switch the backend parser in that way. It's gotten a lot easier today. And in fact, if we go right back over to the code, one of the other things that I've been doing recently, and this is sort of, shout at me if this is insane. I actually came from Python by way of Haskell, never written Java before. So I tried to make it so that the guardrail project is modularized so that you as a consumer don't have to bump your dependencies every time anybody sneezes in any of the other modules. One of the biggest problems that we've had is there's one monolithic guardrail version number. As a result, there's like, okay, so somebody changed something in HTTP4S and now the Akka people need to change, or somebody changed something in Java land and now everybody has to change somewhere else. And I want to add Python support. And it's like, okay, well, how does that look like? There's this kind of forcing everybody to rebuild and version their projects just because we changed a version number, but there's no, semantically, there's no underlying change at all. And requiring people to actually understand the version numbers, it's a losing battle. So I've broken all the modules up. So now we actually have each of these like core, the Java prefix ones, the Scala prefix ones over here. All of those are now different JVM dependencies, different jars. And additionally, because they're different jars, you can actually pin a newer version for a jar, so long as it's backwards compatible. We use Mima to enforce forward and backwards compatibility. So the intent is to get to a place where you add the build plugin to your project, and then you try to run the project and the project rejects because you don't have the dependencies that you need. You add those dependencies and it kind of guides you through the Primrose path to get where you need to go. But then once you've got your dependencies explicitly specified, then you can manage the version bumps for those explicitly. If you're using Scala Steward, it'll automatically bump versions for you, all of that stuff out of the box. So I want that world. I tried to do it using reflection hell, kind of catching class not found and all of that. It was a huge mess. So I ended up going to the thing that was there from the beginning, which is SPI. And I don't know if that's the right thing to do, but it seems to be working well enough. So I'm using Scala's type reflection to encode the reified types so that I can reflect out and filter the SPIs based on types that have been encoded in the classes. And that should give the level of confidence that we're calling the right languages and not just ending up with runtime failures. So I hope it works. But that should get us into a place where even the core, the reason I'm mentioning this, the core is where the majority of source. So the core is the majority of where the Swagger parser stuff lives. We translate it into our own domain models. So I could see a world where the core is Swagger OpenAPI agnostic, or converted to the async API, whatever spec. It wouldn't be too far fetched to see that as a future.
That'd be, yeah. So quite the undertaking, but yeah, that'd be, if you get that, that'd be interesting.
The fact that we got Java at all is that was already a huge undertaking. Yeah, the turning all of the Scala generated code into Java or into an abstract thing, it was kind of funny. There's one thing that I'll show to that end. So language abstraction is this is another thing that I'm going to have to rethink for Dotty. I talked to Guillaume, who worked on Dotty. Mm-hmm. He's like, you're using a feature that we removed from the language. It's like, cool, thanks. Why? So as a result, it's a Scala language as a the way that that feature worked now, unfortunately in the past, so you'd have a class and all of these type members would be abstract. And then you have an instance of the language, an instance of that class that supplies all the type members. And then everywhere in the code, you'd actually have stuff like this, where you'd say, if I have an L that is from a language abstraction, then I have a way to project into that field and get the actual type of that thing. So the whole core is language abstract. And you pass in an instance of that thing when you instantiate the runtime of guardrail. And so then it like threads through all of those types. Those things, instead of being type projections, they become real types. And you get real, like, oh, I was expecting this thing and I got this thing. And it all works. There's no reflection throughout the whole code base. So yeah, it's a remarkably complex project, but the type errors are really useful. So yeah.
So did Guillaume give you any, like, do you know the route to take for Scala 3 then for that?
Type paths. I need to, instead of passing around the, like I need some object that is a subtype of this, or some type that's a subtype of this other type. I have to change that into that thing, as well as an instance of L is an L, and then L dot, and
L dot, yeah.
it's like, oh, that's going to be huge. It's going to be a massive change. So fortunately, I've actually put a couple of videos on the internals of Guardrail on YouTube. And one of them was using ScalaFix to Guardrail internally used to not be principled hardly at all. It was principled in what it output, but not how it got there. And then at some point, I wanted to understand how free monads worked and how it could benefit me. So I learned free monads enough to be able to rewrite Guardrail in the free monadic style. And it worked, and it was actually really great. And it gave us a lot of functionality that I wouldn't have otherwise expected. And it was actually really fast too. So it was much faster than previously, surprisingly. And then I saw tagless final as a way to get better user experience. Because one of the things that, I use Vim, I didn't even use metals at that point, it didn't exist. And so the problem that anybody who came to try to contribute had was they would open Guardrail and it would be a sea of red, because nothing could understand free monads. Like IntelliJ couldn't understand free monads. Like, what are you going to do? So people were just not contributing because it was just such an undertaking to get the project to open. And I never saw any of that problem until one of my co-collaborators, Brian Terracone, was like, yeah, I don't really use like any of the advanced features in IntelliJ. I just like that it's consistent across my machines. So when I see that it's just a sea of red squiggles, I just read the code and I understand what's going on. But yeah, it's just been broken from like the day that I started contributing to your project. It's like, you didn't tell me. Why didn't you tell me that it was broken? So I learned ScalaFix, and I wrote a ScalaFix rewrite that actually just in one but swell whoop with no, I was actually surprised at how well it worked. It converted all of the free monadic code into tagless final, and now we've got great error messages. But yeah, it was all just a giant ScalaFix rewrite. Just one of the benefits of working with Scala Meta and being familiar with it is just like, yep, I can just kind of do that. It's fine.
That's great.
Yeah, it was great. So yeah, there's a YouTube video of me writing ScalaFix rules to do that. So if you're a masochist, that's also available.
Cool.
Yeah. So if any other questions, otherwise, I think I'm going to let you all free to live your lives.
Yeah. Appreciate it. Thank you, Devin. This is great.
Yeah.
Thank you.
Thanks, everybody.
Yeah. Have a good night.
Yep. You too.